Okay, for this example, we have x cubed plus 27y cubed divided by 6x times x squared minus 3xy divided by x squared minus 9y squared. Okay, well let's start at the top left expression here and see what we can do. We have x cubed plus 27y cubed. So as soon as I see those cubes, I'm thinking sum of cubes. Anytime you have two terms, 1, 2, right, and there's cubes involved, like the number 27, you might see something like 8, 125, or 1, and then you have x cubed, y cubed, then you should think sum of cubes. And there's a formula for that. It's the SOAP formula. Here it is. Let's pull that into the mix here. Okay, so there's the formula for the sum of cubes. A little bigger. Okay, so a cubed plus b cubed, and this is something you should memorize, right? It's no fun, but you just have to do it. I call it the SOAP formula because of the signs: same, opposite, always positive. SOAP, right? That's how you can remember the signs for these things. Know that this is AB and not 2AB. Okay, so doing that, sometimes it's a little bit of a question on how we fit this into the SOAP formula. So let's just go up here and rewrite that. This is x cubed plus, instead of 27y cubed, we can write this as 3y quantity cubed. Right, so then this x is our a and our 3y is our b. So then we use the formula a plus b, so x plus 3y. Okay, so there's a plus b. And then we have a squared, so x squared minus ab, so 3xy plus b squared plus, so that would be 3y squared, 9y squared. Okay, make sure you square the entire b term there. So this is a squared minus ab, b plus b squared. Okay, so, but when we say b squared, this is your b, so you have to make sure you square the entire thing, which gives you 9y squared. Okay, so that's that term there. Let's rewrite it down here. X plus 3y, and then we had x squared. That would be a minus 3xy plus 9y squared. Okay. And when we're multiplying these two rational expressions together, you just multiply the tops together. So you kind of just squash the tops together and the bottoms together. So you can think of this like this, right? 6x here and then these here. Okay, so multiplying is really nice. How can we factor this term on the upper right-hand side here? Well, I'm thinking we can get an x out of that. So let's pull out an x. That's the greatest common factor. That leaves us with x minus 3y behind. Okay, down here, well, we still have 6x hanging out. And now we have x squared minus 9y squared. Well, anytime you see two terms, but they're both squares and there's a minus between them, you should be thinking of the difference of squares formula. Difference of squares, something like this. There we go. That's our difference of squares. A squared minus b squared is a plus b, a minus b. Okay, so no problem. X plus 3y, x minus 3y. Right, because we can rewrite this if we were so inclined as x squared minus quantity 3y squared. And then we could see where this would be our a, this would be our b, and you can see where how this breaks down. Okay, now for the canceling. Let's see what we can cancel. Check it out. X plus 3y cancels x plus 3y. What else? Oh, x minus 3y cancels x minus 3y. We also have these x's. Look at this. There's an x, cancels with this x. Okay, so now it's starting to look a little messy, so let's clean it up and see what we're left with. Okay, so we're still left with this x squared minus 3xy plus 9y squared divided by 6. And that's all we can do. Right? You wouldn't want to try, you don't want to try factoring this bit here, this top trinomial, because it came from the sum of squareds formula. And if it came from that, it won't be factorable. So don't waste your time trying. Just leave it as it is. We can't cancel this 6 with the 9 or anything because we don't have anything out front. We'd have to cancel the 6 with each and every term in this trinomial. So that's all we can do. There's our answer.